Hi everyone, this is example 15 on unsteady flow. A concrete spillway controls a reservoir having an area of 6.8 hectares. The length of spillway is 9.6 meters. Using the Francis formula, how long will it take for the water to be drawn from elevation 116 meters to elevation 114 meters after removing the flashboards? Assume the crest is at elevation 112 meters. Then next question, if the water after removing the flashboards is drawn from elevation 116 meters to elevation 115 meters in 23.62 minutes. Determine the elevation of the crest. Then if the permanent crest is at elevation 113 meters and water is drawn by removing flashboards from elevation 116 meters, what would be the final water surface elevation after 50 minutes? So let's draw the situation. We have here the reservoir and the outlet would be this spillway, which is in the shape of a rectangle, which serves as a weir, rectangular weir. So the crest is in the first part is at elevation 112 meters. The water surface elevation is initially at 116 meters. So this is at 116 meters. Then for the first question, it should drop to 114 meters. Then crest is at elevation 112. So the head is measured from the crest to the water surface, and in general it is variable, and the outlet is aware. So meaning the final head is 2 meters when the water surface drops to 114, elevation 114. That is 2 meters. The initial head is 4 meters. Then area S is 6.8 hectares, 68,000. When the water surface drops, the area, which is very large, 68,000 square meters, remain unchanged. That's the idea. So area S is constant. The general formula for to time for the water surface to drop from initial to final is integral of area S dH over Q out, where Q out is Q of the rectangular weir using Francis formula, which is 1.84 LH to the 3 hubs. So that's the head at any time. So length of crest is 9.6. This is the formula, area SDH over 1.84 LH to the 3 hubs. This is by Francis formula. So L is constant. The variable here is H. So substitute. Time is integral from 2 to 4 because the surface is drawn from 116 to 114 and the crest is at elevation 112. So final head is 2, initial head is 4, 116 minus 112. So computing for the constant, you'll just copy the constant, then integral of dh over h to the 3 halves is integral of h to the negative 3 halves, which is h to the negative 1 half over negative 1 half. So the integral is negative 2 h to the negative 1 half. So 68,000 over 1.84 times 9.6 times negative 2 h to the negative 1 half from 2 to 4. Substituting values, negative 136,000 over 1.84, 9.6. H to the negative 1 half is the same as 1 over square root of h. So 1 over square root of 4 minus 1 over square root of 2. Solving for the time, and it is equal to 1595 seconds. For the second part, if the water after removing the flashboards is drawn from elevation 116 to elevation 115 in 23.62 minutes, determine the elevation of the crest. So since the elevation of the crest is not at 112 anymore, so if this is at elevation 115, its distance from the crest would be unknown. So let's call that y. But the initial head is y plus 1 because 116 minus 115 is 1. So this is 1 meter. So the initial head is y plus 1, the final head is y. So same formula except for the limits, but the time is 23.62 times 60 seconds equals negative 136,000 over 1.849.6, then times 1 over square root of upper limit minus 1 over square root of lower limit. So solving for y using the calculator, y is 1.5 meters. Then therefore the elevation of the crest is 115 minus y. So the elevation of crest is 115 minus 1.5 and it is at 113.5 meters. And finally, for the last question, if the permanent crest is at elevation 113, so the elevation of the crest is known, 113, and water is drawn by removing flashboards from elevation 116. So meaning to say, initial head is 3 meters, 116 minus 113. What would be the final surface elevation after 15 minutes? So we do not know the final surface elevation, so its distance from the crest is also y. But the final head is y, but the initial head is 3. Using the same formula, then 50 times 60 seconds per minute is 3,000 seconds equals negative 136,000. We just copy this. 1.84 times 9.86, quantity 1 over square root of initial head, which is 3, minus 1 over square root of final head, which is y. So simplifying, negative 0.38965 equals 1 over square root of 3 minus 1 over square root of y. So 1 over square root of y is 1 over square root of 3 plus 0.38965, and that is 0.967. So 1 over 0.967 square is y, and y is 1.069. Therefore, the final water surface elevation is elevation of the crest 113 plus y. And it is at 114.069 meters.